we're going to review some theorems that we've learned that are really important for this chapter, and they are VAT, RAT, and BAT. Right, I've got some lovely pictures here for you, but let's talk about what they really mean in terms of geometry. So VAT stands for vertical angle theorem. And the vertical angle theorem, I hope you know by now, the vertical angle theorem says all vertical angles are congruent. So let's draw a picture to go with that. So remember, vertical angles are formed by intersecting lines. So we've got, we'll label these 1, 2, 3, and 4. So according to the vertical angle theorem, angle 1 is congruent to angle 3. Those are vertical, so we can mark that, arc and arc. And 2 and 4 are also vertical angles. 2 is congruent to angle 4. And let's put double arcs, double, double on those angles. So this, we've studied this for many chapters now. You should be pretty familiar with that. The RAT is the right angle theorem. This was last chapter, maybe even chapter 2 when we learned this. We haven't been using this as much, but it's still just as important. The right angle theorem says all right angles are congruent. All right, so let's draw some right angles. Let's see, this one right here, we'll call this angle 7. And let's draw another right angle over here. Call that angle 8. So according to the right angle theorem, angle 7 is congruent to angle 8. Right, they're both 90. This theorem should make sense to you. Now this is the new one that we learned yesterday, and it's the BAT, the base angle theorem. The base angle theorem says in an isosceles triangle, the base angles are congruent. Or you can do the converse, which would be if the base angles are congruent, then the legs are congruent. So we'll just put that in here. And legs are congruent. You can go either way. If you see base angles, you know legs. If you know legs, you know base angles. So we'll do 2 different examples. So in this picture, let's call this triangle A, B, C. I see 2 legs that are equal. So according to the base angle theorem, if 2 legs are equal, the base angles are equal. So there's one application of the base angle theorem. Another application would be the reverse, where, let's call this triangle D, E, F. If you see base angles that are equal, then you can say that the legs are equal, and the legs are always opposite. So DE is congruent to FE. So either of these are for the base angle theorem. So now hopefully you can use this as a reference sheet so you can use these theorems properly.